Unit 3, Part 1. We just went over this. I'm not going to spend a whole lot of time on this. If you need that study guide, there are tons of study guides out there. Please ask your teacher for practice problems. Please do whatever you need to do to figure out the misconceptions. Work through those practice problems in your exam final. Do what you need to do, okay? I'm going to do a very brief overview, and we're going to go through this quickly. The first part, the first 20-something pages in your packet, are talking about the different ways of how do we find and solve these polynomials, okay? The first step when we're solving these polynomials is to find all possible roots, okay? All possible roots. Why do we do that? Because we need to figure out what we can use to do what? Synthetic division. So we can get our polynomial down into a quadratic. Everything comes full circle here. Everything that we have learned all semester long comes full circle to this unit, okay? We're using the division properties, okay, to find all possible roots, all right? All factors, all of that. We're finding all the possible roots, and then we're identifying which root will get us a synthetic division problem with a remainder of 0. When we get a remainder of 0, we know that that is, in fact, an x-intercept. It's a 0. It's a solution. It's a root, okay? You have to make sure you understand that vocab, okay? You have to understand that vocab. After that, we can use, once we get it down into a quadratic, okay, after we do synthetic division, we get it down to a quadratic, we use the 4 different methods, okay? Now, this is where you need to play it safe. If all else fails, you can do the quadratic formula. I don't recommend it for time's sake, but you got to do what you got to do sometimes, okay? After this, okay, you're going to have different types of roots. You're going to have rational, irrational, and imaginary roots, all right? So you've got to figure out which one is which. You got to make sure you have the I. You got to make sure you're simplifying the radical. All of the things we've learned, full circle, okay? Now, the second part of that packet is graph characteristics, degree, your roots, and multiplicity, okay? Does multiplicity, remember, if you have x plus 2 all squared, that means you're going to have 2 multiplicity 2, or excuse me, negative 2 multiplicity 2. I'll get an example of that in just a second. Symmetry, even, odd, or neither. Even means you have all even exponents. The constant is considered even because there is an understood x to the 0 power. What did I say x to the 0 power was? If you said 0, pop yourself on the hand. It is not. It is x to the 0 power is 1. So a constant times 1 will give it itself. That is why it works. Odd. An odd function is a function that has all odd variables. Okay? And then neither is when you have a mixture of even and odd variables. You need to figure out the domain and range. You're going to need to figure out end behavior, the intervals of increase, decrease, and your y-intercepts. Other things that you need to make sure and take care of. These critical points, your absolute min and max. Okay? Is there a point where your graph goes no further? Does it have an absolute stopping point? Okay? Does it have a peak? Does it have a valley? What do you have? Understanding if it's relative or absolute. And then you have turning points. At most, it's going to be your degree minus 1. So, if you have, just for example's sake, just very quickly, x cubed minus 2x squared plus 6x minus 2, at most, your turning points. What do I mean by turning points? I literally mean these things, the valleys, all right? You're going to have at most 3 minus 1. Do I have at most 2 turning points? Yes, this is 1 turning point, and this is my second turning point, okay? That is what I mean by turning points, okay? If you need notes on this, if you need to go through these examples, please come to after-school tutoring. Please find my notes online. If you're in my class, it's in the Aspen folder under Unit 3, Part 1. This is all the things we've talked about. We've done this 1,000,005 times. We just took a test on this, or we're about to take a test on this. Even with a snow day, you have to take it. These are all things that you need to know. So I'm going to go through one example of the roots, and then I don't know if I have any graph pulled up. I might be able to get to one on my computer, so let's check it out in just a second. All right, let me erase. If we're given the question, find all roots of the following function. Just in case, I'm going to pause this to make sure I have the correct one. Okay, I'm back. We have f of x equals 3x cubed minus 5x squared minus 4x plus 4. Okay, the first thing we need to do is find all possible roots. P over all the factors of q, all factors of p over all factors of q equals plus or minus 1, 2, and 4. And then plus or minus 1 and 3. So we have to finish it by dividing plus or minus 1, 2, and 4 all over 1/3, 2/3, and 4/3. So at this point, I would put it into your graphing calculator and graph this solution. Okay? What you will find is a possible rational root. It crosses the x-axis, aka your x-intercepts, at -1. So this is what I will use to do synthetic division. Bring down all of your coefficients. 3, -5, -4, and 4. And then synthetic, use the division. Let's go. Drop the 3, multiply. -1 times 3 is a -3. This becomes a -8. -1 times a -8 becomes a +8. This becomes a 4. -1 times a +4 is a -4. This is 0. Is this a root? Yes, it works. This becomes your quadratic. This, if we remember, this is your constant, this is your x, and this is your x squared. So now we have the quadratic. 3x squared minus 8x plus 4. Can you factor this? Can you figure that out quickly? No. Okay, so what you're going to need to do, can you take completing the square? No. Can you use it taking the square root? No. What you need to do is the quadratic formula. Now, for some of you, you can see that it factors and go for it, you guys. For those of you who can see it, go for the factoring piece of this. But it's very hard for me to see the factoring piece of it, so I'm going to use the quadratic formula. -8 is my b, and I know that that has to be, you have to flip the sign because it's -b, plus or minus the square root of b squared -8 squared minus 4 times 3 times 4. 4ac, all over 2 times 3. What you will figure out is this is 8 plus or minus. What you're going to find out is that it's the square root of 16 all over 6. Now, 16 is a perfect square, so we can go ahead and simplify that to 4. All right. Now, since that was a perfect square, this quadratic can give you whole numbers or real numbers. Okay, not real, but rational. They're real. Rational numbers. So, your two solutions will be 8 plus 4, which is 12, divided by 6. That will give you a solution of 2. And then 8 minus 4 is going to give you 4 over 6. That 4 over 6 can be simplified to 2/3. Do not be afraid of those fractions. So now we have to put it all together. All right? All together, you're going to look at a a solution as follows, okay? Our solutions, x is equal to -1. How did I find that? That's what we used to do the static division. 2 and 2/3. Do we have all the solutions to that polynomial? Well, since it's a third degree, we have 3 solutions, so this checks out. And that is how you would find the solutions to that polynomial. If you have questions, please make sure you ask your teacher. All right. Now, bear with me because we're going to go ahead and figure out and look at a solution for graphing characteristics. All right. Now, I gave some of this to you. I don't know if I want to do any of those. Let's look at, pause for a moment. Let me find this. Okay, so I found it on my computer. It took me a second. We're going to look at this. It's given to you. This is one that's given to you. You're going to have it both ways. You're going to have it when it's given to you and when it's not. But for right now, I'm going to focus on what if they give you a graph? What can we tell from just this graph? Okay, this graph right here, all right, what we're going to look at is the degree. And how do we know? Now, in the previous slide on the very beginning, we talked about the turning points. The degree is always n-1, or the turning points are always the degree -1. So in order to tell the degree of a function from a graph, you need to count your turning points. We have 1, 2, and 3, all right? Now, are there any special characteristics of this graph? Is there any bounce points? Is there anything where we need to watch for multiplicity? And I'm going to say no, there's not. So, what we're going to do is this. If we have 3 turning points, the degree is at most, what? 4. Okay, if the turning points are n-1, 4 minus 1 is 3, that works. Also, another reason why it can be 4 is, look at my n behavior. They're both pointing up, okay? Only even degree functions are pointing up or down, okay? They match each other. So, with that, we can determine that this is a 4th degree polynomial. The domain. The domain of any of these functions, believe it or not, ladies and gentlemen, is always dealing with your x-axis, okay? Your x-axis is this horizontal line. And how do I tell the domain? Well, I look at where this is going, okay? So we start to read the graph always for the domain from left to right, ladies and gentlemen, left to right. And we see that this is going on and on forever. Now, it may not be super obvious, but what I do is I draw it down to my x-axis. It is pointing in the left direction. So I'm going to say my domain is pointing in a negative infinity direction. Okay, now my largest point, we do the same thing. We drop it down to this x-axis and it's going to eventually hit every single x value because it never stops. Those arrows tell you it never stops, ever. It goes on and on and on and on and on and on and on. It may be slow, it may take its time, but eventually it will hit every single x value. And that is why it's negative infinity to positive infinity. Now, your range. Your range, we have to look at the graph. You read from the bottom. I'm going to erase those so we can see this. From the bottom to the top. To the top. So, we need to find our smallest y value. And what I do is I literally find the smallest, the lowest point on that graph, and I draw it to my y-axis. That point, I'm going to estimate it. I don't know if it's completely on there or not, but I'm going to say that that y value is going to be -7. Now, is there a parentheses or a bracket? It'll be a bracket. Why? Because if it was going to be a parentheses, there would literally be a hole in that graph. Is there a hole in that graph? No. So we are not going to use a parentheses. We're going to use a bracket. Now, we have to figure out where it's going. Where is my graph going on the y-axis? Well, it's pointing up. Will it ever stop? No. So it'll hit all positive infinity y values. Okay, hit them all of them. So it's going to positive infinity. All right, that's domain and range. The next thing is to identify your x-intercepts. Ladies and gentlemen, your x-intercepts are where it crosses your x-axis. Okay, it's where it crosses your x-axis. Right? How many roots does this have? 1, 2, 3, 4. Further verification that we have a degree of 4. All right, so what we would say is -1, 1, 2, and 3. Those are all the x-intercepts of that graph. They're very nice, gotta say. Y-intercept, it's where it crosses the y-axis. Your y-intercept is going to be right here. And since they asked for the y-intercept, I'm going to write it in an ordered pair. 0, -6. How do I know it's 0? Well, we're not going anywhere on this y-axis, are we? No, we are not. On the x-axis. We are not going in anywhere, any direction. Remember, ordered pair is always x, y. So I know if I'm not going anywhere on my x-axis, this will always be 0. And then wherever it is on the y-axis, that'll be that number right there. Okay, relative maximum or minimum. Okay, the one thing that this does not talk about is absolute. Okay, but we'll talk about the relatives. Let's talk about the relatives. Okay, the relative max and min, okay, is exactly how it sounds. All right, what's my maximums? What's my mountaintops? What is my peaks? Where are those points the tallest? Okay, it's relative because, all right, it's a relative maximum because look, will we ever have a place, a mountaintop that is going to top everything else? No, these arrows right here are always pointing in the positive infinity direction. You will never have an absolute maximum for this function. But we do have a relative one. This relative one, ladies and gentlemen, is right there. All right, I'm going to estimate it to be what's halfway between 1 and 2. That's going to be 1.5. This is for this one. 1.5. All right, 1. That's 1 on the y-axis. Okay, that's my relative maximum. Okay, now your minimums. We have 2. We have 2 minimums. I'm going to see if I can use a different color so I can show you this. We have a point here, okay, a point here, and then a relative minimum here as well. Now, one of these is an absolute minimum. And at this point, I hope you can figure out which one it is. This is not the smallest valley. This is not the lowest valley. This is really not the lowest point. The lowest point is this over here, okay? So when we're talking about this, they're both relative, but this is also an absolute minimum. And if I got that wrong, please, teachers, don't kill me. Please correct me, and I'll make sure to do it. I'll make sure it's correct the next time around. So, minimum. We have the first one is going to be absolute, which is right there, and then this is my relative. Whoop, whoop. This point is going to be at 3.5. Again, I'm estimating. Parentheses, -1.2. Okay? If you got close to that, then that's okay. All right, I'm okay with that. Here, this is your absolute. This one's going to be at 0.5, a -0.5 on the x-axis. All right? And then all the way down at -7. And that is your absolute minimum. Now, last but certainly not least, the end behavior. I like telling my students to find this first so we know what kind of degree we're looking at, what kind of function it is, whether it's positive or negative. Now, as x goes to negative infinity, so as this is going to negative infinity, what's happening to your function? What's happening to this y value right here? What's happening on this y-axis? Y is going to positive infinity, okay? I'm only analyzing the graph. I'm literally looking at it logically. What's happening as these x values get smaller, as this x value right here, x negative, this -1 right here, what's happening to those values? They're increasing. X to the -2, eventually we'll see that it's an increasing value, all right? So what we do for one side, we also have to do to the other side. As x goes to positive infinity, as these values go up right here, what's happening to that? It's also going to positive infinity. That is how you can figure out all the fun stuff about your graphs. And those are examples of what we just learned. Not everything that we just learned. I probably missed a couple things. I know I did. I glossed over a couple things. If you have any questions, any things that you need help with, please make sure you are getting help. Go to tutoring, figure out who's still there, and just figure it out. Thank you, and y'all good luck with y'all's finals.